Hey there, Data Pro. You've come a long way since the beginning of your learning journey. Congratulations on your accomplishment. Just think of all the skills you've learned along the way. You now know how to use structured thinking to define a problem and ask the right questions, work with spreadsheets, databases, and tools like SQL to organize and transform data, clean your data to make sure it has integrity before you analyze it, create impactful visuals to illustrate key points, and craft a compelling story to communicate insights to stakeholders. That's an impressive list of skills, but we're not done yet. Your skill set's about to get even bigger. In this course, you'll learn about a new concept called programming and how you can use the R programming language to analyze your data. By now, you know that the data analysis process includes 6 phases: ask, prepare, process, analyze, share, and act. Now, we'll learn all about the R programming language and how it can help you in each phase of the process. When you're done, you'll be presented with an optional case study. The case study will give you the chance to solve a data analysis problem using all the skills you've learned in this program. You'll find out more about this project later on. Okay, let's talk about computer programming. Computer programming refers to giving instructions to a computer to perform an action or set of actions. You can use different programming languages to write these instructions. You might choose a specific language based on the project you want to pursue or the problem you want to solve. The R programming language is super useful for organizing, cleaning, and analyzing data. If this is your first experience with computer programming, welcome! When I first started learning about data analysis, I didn't have a background in programming either. In fact, before I fell in love with data, I was trained as an opera singer. I also have a lot of friends that came into this field from the arts and learned about programming later in their career. R is a great place to start. Learning R for the first time can be challenging and even more empowering. A lot of the skills you've learned in this program will help you learn basic programming concepts. Take it one step at a time and go at your own pace. And just like in previous videos, you'll start with the basics and move forward from there. You've tackled tough challenges before, and you always come out on top. You've got this. Let me introduce myself. My name's Carrie. I work as a research manager at Google. I lead a team that researches the best way to improve the performance of people in organizations. In other words, I help people work better and work smarter, and help organizations function in a healthy and productive way. I first learned R as a junior data analyst, while I was working on a multi-year project about virtual work. We were looking at data on people's virtual work experiences and trying to understand how working remotely impacts performance. It was a complex project with a lot of data to sift through. I kept encountering problems and searching for better and faster ways to do things. This is when I became aware of the power of R. Whenever I got stuck, I'd learn a little more about R and discover a solution to my problem. I soon realized that R could help me do almost anything involving data, even better and faster than I thought possible. Fortunately, there are tons of great online resources for R and a super supportive online community. If I had a question, I'd go online and find the answer. As the project progressed, I was able to learn more and more and become a much more effective data analyst. My teammates even started coming to me for advice about R. Realizing that I could continue to learn my skills at any stage in my career was an empowering experience. Learning R unlocked my ability to perform data analysis at the highest level. In your future career as a data analyst, you'll have the opportunity to continually learn and grow. To me, that might be one of the coolest aspects of the job, and learning R is one of the most rewarding parts of that growth process. I'm still learning new ways to use R all the time. Plus, you can apply these skills to other programming languages, like Python, Julia, or JavaScript. There's no limit to how far you can go with programming. It even goes beyond data analysis. After I learned R, I found myself thinking about all kinds of projects I could use programming for, both at work and for fun. It opens up a whole new world of possibilities. Now, let's talk about what you're about to learn. We'll start off with an introduction to programming languages. Then, we'll take a closer look at R itself and explore its main features and functions. We'll also cover some basic programming concepts and learn how to use them effectively in R. Next, we'll learn how to work with data in R. You'll discover how R can supercharge your data analysis skills and let you clean, transform, visualize, and report data in new and more powerful ways. Learning R will help you take your data analysis to the next level. It'll also look great on your resume. R is widely recognized as a key credential in entry-level job positions. Knowing how to use R will give you a big boost in your job hunt and will help you stand out as a new analyst. Coming up, we'll talk more about programming languages in general and how they can help you analyze your data. After that, we'll jump right into R. Before you know it, you'll be using R to power your data analysis. When I first learned R, it was the visuals that really got me hooked. I still think it's so cool that you can write a little bit of code, press a button, and presto, out pops an awesome data visualization. Before we get into all of the details, I thought it would be fun to give you a quick sneak peek and show you what R can do. What follows will be a preview of what you're going to learn. By the end of this course, you'll not only understand all this code, you'll be able to write and execute it as well. For now, just sit back, relax, and enjoy the show. Let's start by loading a library and getting a dataset to work with. We can use the Palmer penguins dataset, which contains size measurements for 3 penguin species that live on the Palmer archipelago in Antarctica. This includes data on stuff like body mass, flipper length, and bill length. The dataset has 344 rows of information sorted into 8 columns. The Palmer penguins data is popular with Analyst and is great for fun exploration, visualization, and teaching concepts. We'll see more of this dataset later on in the course. Let's say we want to visualize the relationship between body mass and flipper length. You may guess the larger the penguin, the longer the flipper. We can find out for sure by creating a plot. Let's make a scatter plot. A scatter plot uses points to display the relationship between 2 variables. So the 2 variables we're going to compare are body mass and flipper length. No need to memorize all these details right now. You'll have time to learn more about them later on. Let's check out the parts of this code and how they fit together. The first function starts the plot. If we run the code at this point, all we get is a blank plot. If we add some more code, R will put labels on each axis of our plot and add lines for data. Body mass is on the y-axis, and flipper length is on the x-axis. But the data points are not yet visible. To get the complete plot, we can add some more code that tells R how to represent our data. For example, we could use points, bars, or lines. We'll use points to create a scatter plot. We can go further. For example, we can change how the plot looks. Let's change the color of all of the points to purple. You can hit the up arrow to pull up the last piece of code you ran, so we'll do that now. And then we'll add in color equals purple inside geom point. Now we can hit enter to run this. We can also add new information to the plot and use color to highlight it. Let's tell R to assign a different color to each species of penguin. This way, we can link data points to each group of penguins. Gentoos are the largest. The legend just to the right of the plot shows us that the blue points refer to the Gentos. R automatically creates a legend for the plot to help us understand the color coding. R does everything you tell it to do, and even does stuff you don't ask for. It's just that helpful. We can also use shape to highlight the different penguin species. Or we can use both color and shape. In addition to highlighting our data, we can also reorganize it. We can break our data down into smaller groups or subsets and create a plot for each subset. Let's say we want to focus on the data for each species. Facet functions let us create a separate plot for each species. Check this out. Facets are so great. We can even put text on our plot to point to specific data or communicate a message. Let's give our plot a title to clearly indicate its purpose. Finally, we can save our plot so we can access or share it later on. Now, if we click on the Files tab, we'll find our file in the list. Let's open it up. Well, that's the end of the show. I hope you enjoyed it as much as I did. We were able to take a big data set and quickly visualize some significant patterns. These are some of the basic functions in R. In other words, this is just the beginning. It's exciting to think of all the ways R can help you realize the full power of data analysis. As you move forward, you'll learn more about each of the functions we use to create our plots. By the end of this course, you'll be the one writing and executing all of this code. Earlier, you learned that programming means giving instructions to a computer to perform an action or set of actions. And even if this is your first time programming, you already have plenty of experience telling a computer what to do. For example, you've probably used a spreadsheet function to sort your data or perform calculations. Or you might have used SQL to tell a computer how to pull data from a database or join two different data tables. Programming goes even further. It gives you the highest level of control over your data. SQL can communicate with databases, but a general-purpose programming language lets you create your own applications and build your own functions from scratch. To program, you first need to know a programming language. In this video, we'll learn about the basics of programming languages and how they can help you work with your data. Programming languages are the words and symbols we use to write instructions for computers to follow. You can think of a programming language as a bridge that connects humans and computers and allows them to communicate. Programming languages have their own set of rules for how these words and symbols should be used, called syntax. Syntax shows you how to arrange the words and symbols you enter so they make sense to a computer. Coding is writing instructions to the computer in the syntax of a specific programming language. Just like the variety of human languages around the world, there's lots of different programming languages available to communicate with computers. There's a language for almost anything you want to do, from designing websites, to developing video games, to working with data. For example, Python is a general-purpose language that can be used for all sorts of things, from working with artificial intelligence to creating virtual reality experiences. JavaScript works well for developing online apps and is an essential part of web browsers. Some other popular programming languages for data analysis include Sass, Scala, and Julia. Personally speaking, R is my favorite language for data analysis. But you might want to explore other languages as well. While programming languages can look different on the surface, they all share similar structures and coding concepts. Once you learn your first language, you'll find it easier to learn others. Coming up, we'll explore R's many capabilities. Before that, let's talk about some benefits of using any programming language to work with your data. I'll highlight 3. Programming helps you clarify the steps of your analysis, saves time, and lets you easily reproduce and share your work. Let's start with clarity. Programming languages have specific rules and guidelines for giving instructions to the computer. When you're telling a computer what to do, your instructions have to be very clear. There can't be any inconsistency in the way you write code. If there is, the code won't work. Translating your thoughts into code forces you to figure out exactly how to write each step of your analysis and how all the steps fit together. It gives your analysis a level of precision that makes it really powerful. Using a programming language for data analysis also saves you lots of time. For example, take the process of cleaning and transforming your data. With one line of code, you can create a separate data set without any missing values. With another line, you can apply multiple filters on your data. This lets you spend less time preparing your data and more time on the analysis itself. Finally, programming languages make it easy to reproduce your analysis. Data analysis is most useful when you can reproduce your work and share it with other people. They can double-check it and help you solve problems. Code automatically stores all of the steps of your analysis. So you can reproduce and share your work at any time in the future, weeks, months, or even years later. Here's an example. Let's say you're working on a project. You've collected and cleaned your data and started your analysis. But the results don't add up. You suspect a mistake was made in the process. You'd like to discuss the issue with a teammate and get their feedback. If you used a spreadsheet, you both might have to redo the entire analysis to discover the error. There's no easy way to record and reproduce your steps in a spreadsheet. But if you use a programming language, all your work can be reproduced and shared in a moment. From loading the data to creating visualizations to reporting the results. Plus, you can easily update your analysis and fix any errors simply by changing the code. I hope that gives you a better understanding of what programming languages are all about. Next up, we'll check out R in more detail. See you soon! So, what is R? R is a programming language frequently used for statistical analysis, visualization, and other data analysis. Later on, you'll take a tour of RStudio, which is a popular software environment for the R language. In this video, we'll discuss R's main features and functions and its advantages for data analysis. R is super cool. I'm excited for you to learn about it. R is based on another programming language named S. In the 1970s, John Chambers created S for internal use at Bell Labs, a famous scientific research facility. In the 1990s, Ross Ihaka and Robert Gentleman developed R at the University of Auckland, New Zealand. The title R refers to the first names of its two authors and plays on a single letter title of its predecessor, S. Since then, R has become a preferred programming language of scientists, statisticians, and data analysts around the world. There's lots of reasons why people who work with data love R. I want to share 4 with you. R is accessible, data-centric, open source, and has an active community of users. First, R is an accessible language for beginners. Lots of people without a traditional programming language learn R. I should know, I'm one of them. R really appeals to anyone who wants to solve problems that involve data. And that's one of the things that's so great about R. It's all about data. R is what's known as a data-centric programming language. It's specifically designed to make data analysis easier, more efficient, and more powerful. Another awesome thing about R is that it's open source. Open source means that the code's freely available and may be modified and shared by the people who use it. Let's pause for a moment and unpack how amazing this is. First, anyone can use R for free. Second, anyone can modify the code, fix bugs, and improve it. In fact, over the years, lots of excellent programmers have made improvements and fixes to the R code. For example, Anyone who knows the R language can create what's called an add-on package. We'll talk more about R packages later. For now, just know that literally thousands of R packages exist, and they were all built by people who wanted to solve specific problems. A lot of these packages are super useful for data analysts. As an R user, you now enjoy the benefit of this shared knowledge. And let me just add, the R community is the best. This vibrant, diverse, and accessible community is so supportive of new learners. You can go online anytime to find answers to all your R questions. Check out websites like R for Data Science Online Learning Community and RStudio Community. On top of that, R users are all over Twitter and other social media. You'll discover tons of resources for professional networking, mentoring, and learning. Now that we know more about the general benefits of R, let's talk about some specific situations when you might use it for data analysis. Here's 3 scenarios: reproducing your analysis, processing lots of data, and creating data visualizations. First, R can save and reproduce every step of your analysis. Earlier, we discussed how data analysis is most useful when you can easily reproduce your work and share it with others. In R, reproducing your analysis is as easy as pressing a button on your keyboard. Your code stores it forever, and you can share it with anyone at any time. Processing lots of data is also something R does really well, just like SQL. As you learned earlier, spreadsheets organize projects in sheets or tabs. If you've ever had to deal with spreadsheet files that have tons of sheets or lots of data in each sheet, you know that things can start to move very slowly. Working with too much data in a spreadsheet can even cause crashes. R can handle large amounts of data much more quickly and efficiently. Finally, R can create powerful visuals and has state-of-the-art graphic capabilities. As you've seen in this program, tools like spreadsheets and Tableau offer lots of options for visualizing your data. R's on another level. With only a small bit of code, you can create histograms, scatter plots, line plots, and so much more. And that's just the beginning. If you work with more advanced packages, you can make some seriously impressive data visualizations. Learning R is a huge benefit to anyone interested in becoming a data analyst. As I mentioned earlier, knowledge of R will help you stand out as a job candidate. And as you keep moving forward, R will help you find solutions for more complex data problems. You can keep learning about R throughout your career as a data analyst. The sky's the limit when it comes to developing your data analysis skills. That's all for now. Coming up, we'll check out the RStudio environment together. Before you use RStudio, you need to download and install the basic R interface. You'll learn how to do that in an upcoming reading. Most analysts who work with the R language use the RStudio environment to interact with R, and not the basic interface. That's why we're focusing on RStudio in this program. Following this video, you'll find resources for downloading R and RStudio if you're interested in learning more. Bye for now.
Congratulations on finishing this video from the Google Data Analytics Certificate. Access the full experience, including job search help, and start to earn the official certificate by clicking the icon or the link in the description. Watch the next video in the course by clicking here, and subscribe to our channel for more from upcoming Google Career certificates.